Demonstration. The title is SmashFileFuzzer. I'm Komal Randive, coming from Symantec Corporation. As a background, I'm a member of the Symantec Product Security Group. This is a group in Symantec which deals with the defensive techniques to strengthen the security in the products. Many of the best practices that we follow to ensure good security posture for the products are contributed back to safe code. This is the URL. I would encourage all of you to actually go and have a look at the details of safe code at safecode.org. Let's have a quick look at the agenda that we have for discussion today. I'll begin with why file fuzzing, and mainly why file fuzzing topic to be presented in a security conference which deals with web application security. Followed by that, we'll discuss the details of the SmashFileFuzzer tool, the file categories that this tool deals with, what kind of a control does this tool provide the user to generate greater amount of controlled fuzz files. After that, we'll move into the demo to see the tool in action. We'll discuss the future of the tool at the end of the presentation. Now, why file fuzzing, and what does the tool for file fuzzing mean? Essentially, any application which runs on a computer has various sorts of ways in which it can take input. Network ports, environment variables, user inputs, and the files are the major source of input for any of the applications that we deal with. The application processes it, generates the output. Simple. Now, what if any of these input sources are under the control of the attacker? If any of these sources provide a malformed input to the application, the result could be a system compromise also. When I'm talking about input sources, file is a major input source which deals with data in transit and data at rest in the application. If these files are malformed in terms of the content and in terms of the metadata, then the application which is consuming, if it is not strengthened enough to handle the malformed file headers, the file data, then the applications are most probably going to crash. And when we are talking about applications which are going to be hosted nowadays, most of the times we are moving to a hosted model of applications, wherein web application would be everything, like everything is in the cloud and I'm accessing from my end. Then the trust boundaries for the applications are fading away. So every input source has to be very well scanned and guaranteed that it provides a clear input or clean input. And hence, we have the tools which can generate fuzzed files intentionally and then test the target application if the application can handle the fuzzed files properly or not. That's the intention of the FileFuzzer tools. Now, we have so many FileFuzzer tools existing which deals with different kind of approaches of generating fuzzed files. Then why do I need a separate tool again? The motivations are like this. One is controlled fuzzing is important because if I take a file as a bit stream and just flip-flop the bits and modify the content and provide an absolutely randomly modified file to the application, and I want to test if the application handles this malformed file properly or not. The problem is the application is going to throw away the file at the beginning because it's basically randomly modified, and if there is a small amount of type checking or format verification that the application does at the beginning, the application is going to say this is a wrong file and throw it away. So we have to have a smarter way of generating fuzzed files in a more controlled fashion. Like I have to understand the file as a complete bunch, separate the byte ranges, understand the meaning of them, and then fuzz it accordingly. So that's more important. So when we have to go for a controlled fuzzing, we have to deal with the understanding of the file format. The tool which is going to generate the fuzzed files has to understand the file format as a complete chunk. But the difference here comes is that if I have to write a fuzzer which will give me fuzzed files of file type ABC, I have to understand the complete file format. And it becomes even more tricky if the files are embedded in between, like a presentation has an image. So a PPT format has some JPEG into it. So the complete file is more complicated, and I have to understand the complete file format specification in order to fuzz the file brilliantly. So that's the basic hurdle when we come to the format-based file fuzzers. So we thought of generating a tool which will deal with understanding of partial file formats and even then would be able to generate valid fuzz files. I've just mentioned the compound file, that is one file is embedded into another file and then I have to generate the complete file format of the embedded file to generate a valid fuzz file. And coverage and compliance. If I go about doing random modifications to the file and generate a lot of fuzz files and test if the application is strong enough to handle this, I would not be able to guarantee the coverage and the compliance of the target application. So essentially the motive of this tool is to generate files which are fuzzed in their content, and these files will then be fed to the target application to verify if the target application can handle these fuzz files cleanly, clearly and strongly. So these are the motivations for generating a new file fuzzer tool. This is a SmashFileFuzzer tool. Let's see what it takes in as an input. One is the file format specification, because this works on the format understanding. So it has to be given the file format. The language for writing the file format specification is proprietary to this tool. You will find it in the README for the tool. It is a sample-based file fuzzer. That means it will take one sample file and generate multiple fuzzed files out of the source file. So it has to take the sample input file. So if I have to generate fuzzed files for doc format, I'll provide any sample file of doc format here, or maybe WAV format. After that, the input is the fuzzing configuration, because we claim that this tool will provide the user an ability to generate fuzzed files in a controlled manner. So this fuzzing configuration will let the user specify what to fuzz and how to fuzz. So before that, fuzzing means you have a clean data, you modify it in a manner that the application fails after consuming that data. So fuzzing is to generate something randomly or modify something as a deviation from the clean input. The fourth input that this tool takes is the fuzzing dictionary. Fuzzing dictionary will provide the strings based on attack. So if I have to test an application for SQL injection, so I'll have one category of attack which will include the strings related to SQL injection. And as a result of the whole sources and the processing that this tool, it will churn out multiple fuzzed files, which are then to be fed to the application and see how the application deals with. This is a quick revision of what we have seen in the image earlier. The file format specification that this tool takes in is in its own language. I'll show you a sample configuration file later during the demo. Essentially, the file format has to deal with the fields separated in the file. For example, there is a header which takes in the constant string in the beginning, followed by that there is a length of the data chunk, followed by that there is some flag which says this is going to be a binary blob or this is going to be a metadata blob, something of that sort. So each entity is referred as a field here. The offset of the field and the field hierarchy information is captured in the specification, and also the sequence of the fields. As I mentioned earlier, the fuzzing configuration will contain the information about what fields to be fuzzed and with what kind of attack I'm targeting this field at. So there is a sample line which gives you one entry in the fuzzing configuration. It takes the field name to be fuzzed, the occurrences to be fuzzed. I'll deal in detail about the occurrences later during the demo. Attack type to be targeted for the field, and the length update. For example, there is a data blob and this data blob's length is kept in other field, which is the length field in the header. So when I modify the data, I have to modify the length value as well. So this kind of a correlation is maintained in this. At the end, the fuzzing dictionary has attack specific strings, which lets the users choose the kind of attack that I have to perform on a input field. And also if there is application specific data that has to be put in. For example, if application A deals with media files and it requires that the first few bytes have to be specific to the application. Or for example, you are writing your custom application which takes in a file as an input and requires A, B, C as the first stream of bytes. So the application specific data can be entered over here. So the first strings, first files will be accepted as a valid file by the application. All right. Now we have file types like .txt, .doc, .wav, but the file categories that I consider for this tool are these. They are mainly based on a few characteristics that the files have. First is the standard file formats, wherein the examples could be a RTF, a WAV, or a PNG file. The major prominent characteristics that these standard formats have is the file format specification is very precise. You have the specification docs with you. It contains some magic string, like for RIF format, RIFF is the constant string that you'll find in the headers. And there is a strong hierarchy in the fields. And the data is ASCII and binary. Second category of files are application specific configuration files. So even if your application specific configuration files are not ACL controlled, and the attacker is able to modify few of the contents in the file, and the application consumes the file and then fails in. To test these kind of scenarios, you have to fuzz the configuration files also. Now while dealing with configuration files, the prominent characteristics that they have are their custom defined formats. So the format specification is little weaker, the configuration is little weak. Delimiters are mostly magic strings. For example, it's a colon separated file, or it's a CSV, that is a comma separated file. So it's specific to the application. And the field hierarchy is relatively flat. You have one line per configuration generally. And the data is readable, that is mostly the ASCII data. Last category is kind of the files that you generate out of your C program by writing the binary structures onto the files. So every field length is very precisely known, and hence the file format specification is very precisely known to the tool user, and the data is binary. So these are the broad categories that I divide all the files available for an application into. Now let's look at the highlights of this tool that it provides the user. As I mentioned that partial file format description. So even if I know a chunk, for example, there is a JPEG file. So you have a specification which is pages and pages long. If I have to give it to any application which will generate first files for me, I have to understand the complete specification, write it into the application, and then the application will churn out the files for me. What if I have written my application, which I have to test, doesn't deal with all the fields. It just deals with the few chunks in between. And I have to verify that my application is secure only for that data that it handles. I need not understand the complete format specification, and my work is quicker in that case. So that's the reason I have given the first option. This tool will let you generate valid fuzz files even if you don't understand the complete format and understand only the chunks of the format of the file. Second is targeted attack specific fuzzing. These are some of the options that the tool currently has. If I have to test my application against buffer overflow in field A, so you can specify that precisely, and hence it will give you more coverage and more compliance. So essentially this is achieved by having attack specific strings in the fuzzing dictionary. Higher control over fuzzing is that as against the absolute random file fuzzers, this tool will give you control over fields to be fuzzed in the header, the occurrences to be fuzzed. For example, there is an XML file and the DTD says that one field set can occur multiple times. Or for example, in the resultant XML, it will be the user information for user 1, 2, 3, 4. So these are suppose 4 occurrences of that XML chunk in the file. I'm interested only in fuzzing the data for administrator. So I know that the first field is about the administrator. So I'll say that only fuzz the first one, let the rest of them remain as it is from the sample input file. So the occurrences to be fuzzed are controlled here. Application specific data, as I've mentioned, you can put in the application specific data. And multiple field fuzzing is also provided because if there are two fields that I have to fuzz simultaneously, the combination of values that the two fields can have at the same time can also cause the application to crash. So multiple field fuzzing is available here. Number of fuzz files to be generated can be controlled by the user. And as I mentioned in the beginning, we have a length update option wherein on modification